Good morning everyone. My name is Iris Srinath. I am from CSE department. Today's subject is computer networks. Today's topic about physical layer overview. Physical layer overview. Introduction about physical layer overview. The physical layer is the first layer of the OSI model, responsible for transmitting a raw bit stream over the physical medium, and it defines the electrical, mechanical, procedural and functional specifications for activating, maintaining and deactivating the physical connection. And its primary goal is to transmit data reliably and between devices across physical channels such as cables, wireless or fiber optics. And the physical layer is the first layer of the OSI model and responsible for transmitting bit string and over the physical medium, and it defines the electrical, mechanical, procedural and functional specifications for the activating, and its primary goal is to transmit data reliably and between devices across physical channel and such as cables, wireless or fiber optical. This is the introduction about physical layer overview. And next slide is the functions of the physical layer. Functions of the physical layer is it converts digital data into signals suitable for transmission over the physical medium, and the physical layer manages the physical connection and is responsible for signaling, bit synchronization and data encoding, and it also handles the modulation and demodulation of signals in wireless communication systems. The functions of the physical layer is the physical layer manages the physical connection and is responsible for signaling and bit synchronization and data encoding. It also handles the modulation and demodulation of signals in wireless communication system, and it converts digital data into signals suitable for transmission over the physical medium. This is the functions of the physical layer. And next slide is the physical layer devices. Devices such as hubs, repeaters, networks, interface cards, NICs and modems operate as the physical layer, and these devices facilitate the transfer of bits by establishing physical connections and amplifying signals. They often include hardware components that can convert digital data into appropriate signals for transmission. The devices of such as hubs, repeaters, networks, interface cards, and these devices facilitate the transfer of bits by establishing physical connections and amplifying signals. They often include hardware components that convert digital data into the appropriate signals of our transmission. And this is about physical layer devices. And next one is the transmission media. The physical layer supports various media including twisted pair cables, coaxial cable, fiber optics and wireless radio frequencies. Each type of media has different characteristics regarding bandwidth, distance, cost and susceptibility to interface. Choice of media depends on the network requirements such as speed, security and environmental conditions. This is the transmission media of the physical layer overview. And next slide is the data encoding techniques. Data encoding involves converting digital bits into signals suitable for the transmission media, and techniques include NRZ, Manchester and differential Manchester and encoding methods for optical signals. The proper encoding ensures reliable data transfer and synchronization between sender and receiver. This data encoding technique is data encoding involves converting digital bits into signals suitable for the transmission media, and these techniques include NRZ, Manchester and differential Manchester and encoding methods for optical signals. This proper encoding ensures reliable data transfer and synchronization between sender and receiver. This is the data encoding technique used. And in this picture we can observe physical layer and a data encoding technique used. Next slide is the physical layer standards. Standards like Internet, USB and Bluetooth define physical layer specifications for different technologies, and these standards ensure compatibility and interoperability between devices from various manufacturers. The specify parameters such as connector types, voltage levels, and transmission rates. These standards are ensures compatibility and interoperability between devices from various manufacturers. They specify parameters such as connector type, voltage levels, and transmission rates. This physical layer standards for ATM physical interface and DS1 ATM physical layer interface. This is we can observe this figure. This is a DS1 ATM physical layer interface. In this figure we can observe 193 bits and header, 3 headers and 200 bytes we can observe. First bit from frame alignment, performance monitoring, etc. and second then rest 192 bits for payload, and third cell transmission rate in 1.536 Mbps and support PHD hierarchy. This is the physical layer structure. And next slide is bitrate and bandwidth. This bitrate refers to the number of bits transmitted per second over the physical medium. Bandwidth indicates the maximum data transfer rate supported by the physical medium. The higher bandwidth and bit rates enable faster data transmission but may require more advanced hardware. And this bitrate refers to the number of bits transmitted per second over the physical medium, and bandwidth indicates the maximum data transfer the rate supported by the physical medium. Higher bandwidth and bit rates enable faster data transmission but may require more advanced hardware. And what is bandwidth is simple terms. The bandwidth is the specifically refers to the capacity at which a network can transmit data. For example, if the bandwidth of the network is 40 Mbps, it implies that the network cannot transmit data faster than the 40 Mbps in any given case. And in this given, we have difference between bitrate and bandwidth. And bitrate is defined as the transmission, and bandwidth is defined as the number of the signal units per second. And bitrate is the emphasized computer efficiency, while the bandwidth is the emphasized data transmission. This is about the bitrate and bandwidth. And next slide is the physical layer challenges. Signal attenuation and noise can degrade data quality over long distances or in noisy environment. Interface from the other electronic devices can cause data evaporation and transmission errors. Like physical layer design must address issues like synchronization, error detection, and medium specific limitation. This is about physical layer challenges. The next one is security at the physical layer. Physical security involves protecting physical access to network devices and cables. These techniques include cable shielding, secure facilities, and controlled access to hardware. Encryption is generally handled at higher layers, but physical layer security is crucial to prevent tampering. This is about the security at the physical layer. And next slide is the future trends in the physical layer. Advancements include higher speed and standards like 400G Ethernet and beyond. Emerging technologies involve optical wireless communications and flexible programming hardware. The evolution aims to support increasing data demands, lower latency, and enhanced security. This is about uh, future trends in the physical layer. And next slide is the summary and conclusion. The physical layer is the fundamental for establishing and maintaining physical communication between devices. And understanding the physical layer helps in the designing efficient, robust, and scalable communication system. Thank you.